Hi, welcome to this cadcam video. It is a video of Unit 3. You can see here, Unit 3 is Unit 3, which is the explanation about the topic numerical controls and part programming is covered in this one. And it is a subject of cadcam and Unit 3. And part A, we will be converting numerical controls, and part B, we are going to study part programming. As per the J2 syllabus, it will be a little bit tight section. I mean to say that a long section. Approximately, I think we have covered here 15 to 20 questions, whereas we cover 8 to 10 questions in the previous 1 2 units. So this is a little bit big unit, so you have to be patient and listen to all the topics and write the notes. I request for this to understand the situations. So let us take the first question. What is the first question is what is NC machines? What is NC machines is a numerical control. NC machines means numerical control machines. So not manually operated. Not manually operated is called as NC machines. So numerical controls means controlled by alphabets, numbers. That is possible with only computers. So if a machine is attached with a computer and it is given some part programming, then it is called as NC machines, CNC machines, and DNC machines. Okay, here NC machine is a automated manufacturing tool that operates based on the pre-programmed. So whatever the pre-program you have written on that, it has to work. So in that program, it consists of alphanumeric instructions. So alpha plus numeric, traditionally stored on the punch tapes or cards. We can store anywhere. Now we are using memories here to store the data. To control machines, tool movements like drilling, milling, turning. So what are the operations in the mechanical cadcam field you are going to operate? Means either you have to drill it, or you have to mill it, or you have to turn it. So these are the main operations which you are going to do here. Yes. So what is this? This diagram is showing there is a part programming you have written into a piece of paper, and that you have given to a machine. So or a computer. So it is here in this cadcam language we call machine control unit. This machine control unit is again connected to this processing equipment. One machine is there. This is a machine. We can say it as a machine of multiple tools you can use here: drilling, milling, and turning. Okay, all tools are arranged here. But what operation to be operated? This is decided by the machine control unit. So it uses a machine control unit (MCU) to translate these codes into motion. So codes are translated into motions, increasing accuracy, reducing the manual operator, intervention, and compared to the conventional machines. So this is the way of forming a numerical control machines, and basic components here shown here about diagram. So if I'm going to take the second question. Explain about the NC modes. What are the NC modes here? So NC modes in the cadcam refers to the different methods of controlling machine tool motions. So you have to NC modes refer to the different methods controlling machine tools motions: point to point, straight, cut, contouring, and operational modes like manual, automatica, editable used to translate digital designs into physical parts. So whatever the tool is following is the digital instructions, and it is converting the workpiece into a physical customer. These modes or these NC modes enables cadcam software to stimulate, program, and execute tool paths for milling, drilling, and turning operations. So we are going to do milling, drilling, turning operations. So they should be programmed in the form of a digital design, which will be converted into physical parts. So this is the cadcam NC modes software. Here you can see the design idea is formulated in the CAD. The design is formed here. Wireframe model or surface modeling is formed. Then it is given to this cams, and this cam is going to be generating the tool path, or the tool path it is going to decide for the manufacturing. Then it will verify. Once it is verified, it will be post process. Then it will be downloaded to a NC machine. Then it is given to CNC machine. That the CNC machine will operate inside this one box here. After that, the finished product is coming outside. So this is the way CAD, CAM, verification, post processing, download the NC program, given to this NC machine and finished goods is coming. So here you can see this is the tool path followed by tool path on the workpiece. We have cut we have cut here some designs here, which is a final product here shown in this machine. So I think this is a more explanation about this second question. Let us take the third question. Here in the third question, explain about the NC elements. So what are the NC elements? So numerical control elements. Generally, numerical control means alphas, numerical codes. So elements, they are asking for the elements. In the elements, you can see this cadcam constitute the foundational automated system for manufacturing. So it is a automation as done in the manufacturing sector in the mechanical field, compressing three core components: the program of instructions, the machine control units, and the machine tools. So program of instructions, that is part programming, MCU, which is converting into G codes, M codes, the machine tool, which is having the tool length part to cut the operation. The system translates digital CAD models into precise machine motions, enhancing the manufacturing precision flexibility. So what are the elements means? Part programming, machine tool, machine control unit, that is computer, and machine tool. Three things which are giving you manufacturing preciously means no errors, less errors, and flexibility. We can have flexibility. So in the diagram, it is showing what is CAD, what is CAM. So interactive graphics, they are giving the data, they are taking the data here. The CAD, which is having a geometric modeling, engineering analysis, design review, and automated drafting. So these are the steps. So in the CAD, first they will model, then analysis, their design, and then automate. Then this CAD is having some database sharing with the CAM. This data is gone to database. From database, it is going to CAM. In the CAM, you can see tool and fixture. So totally tool control, G codes, M codes, and the manufacturing. NC programming is done, and that is given to the CAPP, computer aided planning section here. Then PPC and scheduling. After that, you are going to production. If anything is error in the production, it is again sent back to CAM. It will correct. It will go back to database. It will correct itself. It will go to data CAD. It will correct, and it will go to interactive graphics. It will correct. So total inflow and outflow is shown in the diagram in the NC elements here, which is a very good one. So I think that is enough explanation for the third question. So next question is fourth question. You can see here, explain about NC tool machines and their structures. What are the NC tool machines here and their structures means? The structures of CNC machine tools. Okay, the structures we can see here. The physical structure of CNC machines is designed for highly rigidity. So highly rigidity, they are not simple high rigidity. You cannot change the programs easily. Then precision to minimize the vibrations. There is we have to always trying to minimize the vibrations in the NC machine, CNC machine. So the physical structure is consisting of here bed. It is having base. It is having work table. It is having a spindle. It is having a driving system. It is having guideways. So in the first question also, if you want to refer, I have showed a NC machine there. It is having bed. The foundational usually made up of cast irons. So cast irons absorb the vibrations. So that is what base is used. Work table supports the workpiece moving along X and Y axis. Spindle holds and rotates the cutting tools in the milling operations. So most of the milling is done. That is facing only face. We are remaining facing here. Or the workpiece in the lathes also there. Drive system, servo motors converts the electric signals into MCU into precise mechanical movements of the machine tool. Guideways ensure smooth and accurate linear motion of the table. This is the design, display, and analysis here. So the design, display, and analysis both are given to this CAD. This CAD is giving to this CAM for the tool path motion, or this CAD is converted to digital representation, and from digital representation, it is performing physical models on the workpiece. So I think enough of explanation for the fourth question. So let us move to the fifth question here. The fifth question is asking, explain about the machining centers, types, and features. What are the centers, types, and features? We can see. So some spaces are not given here. Don't worry, So I am here. This one, Windows also I am taking here Windows because Why? Because I'm taking Windows means ma, in order to show you in detail ma, which is possible. Otherwise, it is not possible ma. So here you can see ma, the machining control centers, cadcam are computerized tools. They are the computerized tools. Vertical, they can be centers means they can be two types ma, vertical machine centers and horizontal machine centers. Here in the diagram, you can directly see, no need of explanation also ma. See this, the tool is from top side ma. I can say it is a y axis. In the x axis, the tool is kept. It is cutting in the horizontal bay. It is cutting in the vertical bay, that is the y axis. The tool is kept in the x axis, horizontal. So these are the two types centers. Okay, that is this one. The spindle is vertical here, the spindle is horizontal here, and this is ideally for the flat parts and general milling. Here it is suited for the large, complex, heavy parts. So heavy parts can be manufactured in the horizontal way only. Only some ideal and flat parts can be generally done in the vertical machining centers. Ma. So here these are again tools. It can be vertical VMC we call, horizontal HMC we call. It can be one axis, two axis, three axis, five axis also. Universal also is there, designed for automated multi-operation productions. So these are already automated. Ma. Automation is done. Multi-operation productions. At once they can do milling, drilling, knurling operations. What are the key features of this? Are include automatic tool changers. Nowadays we are using tool changers. Ma. So at a time you will keep all the tools. Whichever the tool has to perform, that tool will come, perform the operation and go back to its position. High speed adaptive roughing, 3D modeling, simulations, automatic pallet changers for reduced idle time. In order to save the time, in order to do more production line, reduce the time, we are going to do ATCMA, that is automatic tool changers are used, which will save our time in the big companies. So I think that is enough explanation for fifth question. Sixth question, you can see ma, explain about the controls in the NC machines. So what are the controls? It is a 2 marks question ma. Actually, I wanted to skip, but I have given here. So this controls in the NC machines involve direct machine tools ma, using coded instructions. So all the code expressions are used for this one. Typically through a machine MCU that interrupts data for media like punched tapes or computers. So what is this controls means? A program is written on the tape. Nowadays we are using memories ma. Before it were using tapes. The controls include the program of instructions. What is there in the controls means? It controls ma. It controls the program of instruction is there, what to do, what not to do. The MCU, the machine computer unit has a tape reader or memory, data buffer. Some space is given for the data buffer, feedback system. If anything wrong is there, it will stop or restart the machine, and the drive mechanism for precise motions. So precise motions to be cut in the this one by using the controls. Okay, the controls here in the NC machines is nothing but a part programming. You can say simple words, the set of programs, set of alphanumeric, G code, M code. You can say here. Next, if I'm not wrong, I'm going to seventh question. Explain about the CNC machines. What is happening in the CNC machines, ma? Explain about the CNC machines. So this is a basic diagram shown here. CNC machine. This is a spindle head. Okay, this spindle it is having a spindle. This spindle is consisting of a tool here, which is performing in the y-axis. Okay, this is a engine base, ma, and also this is a saddle. This can be moved here in the x-axis also and y-axis also. So always we will be having x-axis movement, y-axis movement for the bed, for the tools, for the workpieces. So this is the workbench. We can sit here and we can perform the operations. This is the lathe bed. Ma. Bed is there because this much of weight is to be given to this bed only. Okay, we cannot keep this one down. We have to make a lathe bed here in order to have the weight of this machine to be weighted on this bed. So the operations can be x-axis operation, means in this direction, y-axis, z-axis. Three operations can be done here in this CNC machine. A CNC machine, which is a computer numerical control, is an automated manufacturing tool controlled by pre-program. So pre-programs are whatever the programs you are giving or the softwares. What you are going to do in the pre-program means you are going to give G code and M codes you are going to give. Okay, the recording it is okay now. Here, what is happening is I stopped here only, the recording problem. Recording was stopped, again it restarted. Here, what I am telling is these machines translate cadcam designs into machine instructions for the repetitive, precise production and also improving the efficiency. You can say here. So these machines improve the efficiency, reducing the waste. So no waste is there. They will cut perfectly, improving the sizes. So this is the total a overview of a CNC machine I am showing here. Okay. So what is this? You can see here. Explain about DNC machines. So now we are taping explanation of DNC machines. A direct numerical control DNC machine, which is a system which links multiple CNC machines tools to a central computer via networks. Some network is used for a real-time program transfer, storage, and monitoring. You can transfer a program, you can store a program, you can monitor a program. It eliminates physical media. It also eliminates physical media, allows managing large complex programs. So big programs it can handle and it can cut shape them and streamlines production, making it ideal for the automation in the automotive and aerospace industries. These DNC machines probably are using in the aerospace sectors, automotive sectors continuously because number of programs have to be, number of operations have to be done, which we cannot do on manual operations, time taking. So by machines, we can make these operations very easily here. So here you can see my DNC machines. Here one MCU is there, one CNC machine is there, one MCU is there, another CNC machine is there, one MCU machine is there, another CNC machine is there. So this is the line. Some CNC machines are having their computers, but here NC program is there. That program is kept in the host computer. This host program will give that part program to all these three machines here shown. These three MCUs will supply the part programming to these three CNC machines, and this structure is called as DNC machines. So some CNC machines together operate and produce a final product, and it is an automated process. It is generally used in the aerospace sector, which is a DNC machine. I think you have understand this one. So next I am going to the ninth question. Explain about adaptive control system. So adaptive control system is nothing but just controlling x-axis, y-axis, and z-axis. If any values you are giving, you can control them. See here, estimation controller parameters. So what are the parameters? Generally in the cadcam x, y, z, or theta you can do, which are controllers. This control again going to process and cut the machine here. So this is the controlling of parameters in this section, which is called as adaptive control systems. Here you can also give direct control to the controller will process and give you the final object, or estimate. You can change or estimate this parameters, then you give controller process and this one. Two ways we can manufacture. Adaptive control systems are intelligent feedback based controllers that automatically adjust their parameters in the real time to maintain optimal performances. Okay, real time means when they are running, they are cutting, also they will adjust without stopping the machines. This is what the adaptive control system adapts itself from the feedback. So it will be continuously taking the feedback, it will be updating and it will be doing the work. If any mismatch is there, any varying conditions are there, any significant unpredicted disturbances, also it will feedback it. So it will change itself. It will not stay fixed mind. They are ideal for complex, changing environments such as aerospace and manufacturing. It uses the techniques like gain scheduling, model reference, adaptive system, and self-turning controls to identify and adapt to systems dynamics on the fly. So these are the things where the adaptive control systems, they are simply, you can say, feedback controllers. They will change itself. If any mismatching is there in the process, they will stop. If any varying conditions is there, it will stop. So it is mainly used for the aerospace sector only. So this is the enough explanation for the adaptive. This will come for 2 marks, not for big questions. So this 10th question, next question I'm taking, explain about the types of adaptive controls you can take. What are the adaptive control systems, This is the machine. You can see here, as I said before, this is adjust, compare and measure. Whatever the X, Y, Z value you are going, first it will be adjusted. If it is okay, then it is compared. If it is okay, it will be measured. Otherwise, it will be changing the data with respect to predefined values. This is the adaptive control system. And then it is giving the signal, final signal to the CNC machine. And CNC machine is given for spindle. A spindle is giving for the cutter. The cutter is cutting on the workpiece. The workpiece is supported by table here, which is a block diagram of adaptive control. Here, the adaptive control system automatically adjusts controller parameters in real time to maintain optimal performances. So to give a optimum performance, 95 to 98% efficient performance should be given by the machines. Then only the machines are valued, otherwise not valued. Despite unknown or time varying systems parameters, disturbances, non-linearities, major types include models, reference, adaptive control, MRC, self-turning regulators, STR, gain scheduling, which can be categorized as direct parameter based or indirect model based. So these are having some models here. You can see this is a reference adaptive control system, self-turning regulators, gain scheduling, and a direct parameter based, indirect parameter based. So two types of I have in the shown in the next before question also, direct parameter, indirect parameter. This is also sorry for this disconnectivity. Some disconnectivity problem. I'm again sharing the video. You can see here. So I think the recording automatically stopped. So now it is automatically continuing. Just let me adjust all the controls here. So I'll be continuing from 11th question. I have stopped here. I think I'm not able to see the recording here, but it is saying that it is recording. Okay, 11th question I'm taking here. So here you can see this 11th question. Explain about this. 11th question. I can see, here. One minute. I'm adjusting. I'm adjusting all the things because I don't know I'm recording or not. Okay. So here, what happens is, 11th question. Explain about the fundamental of NC words. So numerical control NC words are the fundamental alphanumeric instructions. So they are taken from the letters and numbers in the cadcam forming commands. Here, here we can see ma, what is happening is explain about the fundamentals of NC machines. So numerical controls NC machines are the fundamental alphanumeric instructions, letters and numbers. So same question ma in the cadcam, forming commands for CNC machines to control tool, tool, tool speed and position. From where it has to move x-axis, y-axis, zero-axis. Speed, what is the speed of the tool? And what are the tools, which tool to be taken? Whether drilling tool or a milling tool. This course primarily having G codes means geometric motions, M codes machine function, form part programming to execute machining operations. Here also you can see what is happening is here the keys elements include letter addresses X, Y, Z, and for feed F we are using, for speed S we are using here. Okay, this defining axis movements, feed rate, and spindle speed. So, what are the main fundamentals? Is you have to be give feed rate, you have to give speed, you have to give position of the tool in the G codes and M codes. This is the fundamentals of the NC machine course. Here diagram also it is shown. Program is given input to the MCU. MCU is having a relation with the processing equipment, which is a basic component of MC machines. So explain about NC codes. What is happening in the NC codes here? In CAD/CAM systems, MC numerical control nodes generally refer to specific data points. What are the specific data points? Geometrical features or functional nodes in a process tree used to define, generate, and manage the instructions. NC codes, G code that control machine tool motions here. These nodes bridge the gap between 3D CAD design data and the final machining tool path. So NC nodes is nothing but NC nodes generally specific data points you give X is equal to so much 10 units, Y is equal to 10 units, Z is equal to 5 units. This is the specific data points where this nodes have to move. This is a geometrical feature now because in order to form the geometry you need all this data. The functional nodes also you can say. What they are doing, they are generating the NC codes and the G codes. This is the one. It is also bridging the gap between 3D CAD design data and final machining here. So here, this is a diagram also which is showing about this NC nodes. So whatever the design you are designing is given to this component CAD. In the CAD, it is model 2D or 3D with some X direction, Y direction. Then it is given for post processing in the CAM. And this CAM is having a part programming CNC machine. In the CNC machine, this part is produced. So this is the one. This is the 1, 2, 3, 4, 5 here. So now this CAM is having some support file, that is a model file, and this CNC machine is having some support files here, drive parameters, unmodified parameters, etc., etc. But yes, you can see here. So the recording problem was there. So don't mind here recording due to this recording problem. I have stopped at this place. The 13th question you can take here. The 13th question explain about canned cycle. So the canned cycle operations we can see here. Here you can canned operations. It is canned cycle is drilling operations. So you can do drilling or milling, anything you can do here. But G81, which is used for simple drilling operation. 82, drilling with a dewell operation. 83, deep holes are make here. G73 code, if you give in the machine, it is giving high speed peck drillings. G84, tapping is given. G80, canned cycle cancels. So once the program is started here, 81, 82, 83, so it is a drilling operation, simple drilling, deep drilling, high speed drilling here, and also 84 tapping canned cycle cancels. So here you can see this is a hole made. Some simple drilling is more. This is a given diameter of 25 in the y-axis. Here also x-axis, it is traveling towards 24 distance from here. The radius is here 18. The radius is 18 here. You can see this one. So this is a drilling bit operation made here. The feed rate, how much the feed rate you have given here. So in the Z axis, you are given 26. So in order the tool to be activated, you have to give this G81 for simple drilling. Then drilling operation is done here. You have to give 82 drilling with dwell tool will change. Dwell tool will come. Tool changer. Then G83 deep holes are made. Otherwise simple holes are made. G73 high speed drilling is done here. Low speed drilling. Speed is decided by this G code 73. And G84 code is tapping. If you want to do tap, here this tap operation is done here. This tap operation is 84. G80 is canned cycle cancels. So in this way, this canned cycle codes, some of the important canned cycles I am explaining here. So next question, 14th question. Explain about the cutter radius. Cutter radius is only one word I can tell that G41 and G42 cutter compensations are done here. Only 41, 42. So cutter radius in cadcam refers to the physical dimensions of the cutting tools. Here, cutting tools often half the diameter. Okay. So cutter radius is radius. It is half the diameter. Used to calculate the tool path offset, ensuring the finished part machine's design dimensions. CAM software uses this radius to shift the tool center away from the part counter G41, 42. So generally one word I will say that G41, 42 are used for the cutting operations. No more discussions about that might be coming for 2 marks. This is also maybe coming for 2 marks only. The length compensation, explain the length compensation. So tool length, this is the taper gauge length. You can see this is a constant machine length. This is a variable length. So the tool has to be vary in this section, variable section. So this is a tool tip. Okay, this is a tool tip. This is a spindle nose, you can say. Okay, this is a spindle which is having some tool in the spindle. So this length compensation is given by 43 G43 code. What it will do, it will activate the tool length compensation in the forward direction or positive direction. Most commonly used G43 only. G44 chooses the tool length compensation in negative direction, backward direction you can go. H code is given in the length compensation, associates a specific offset value from the tool table with the tool in the use. So some specific offset values should be given in the H code. So 10, x-axis 10, forward direction, x-axis -10, negative direction. This H code, you have to give the values. G44, you have to give the values. Then only the tool will operate, otherwise it will not operate. G49 cancels the tool compensation. These 4 tools are used for the tool operation, forward, backward, specific values, and stopping. So, if I'm not wrong, I'm going to take the 16th question here. Explain about the computed assisted part programming using this one. What is happening here is, so here I'm going to explain about some of the computer assisted part programming using APT. So is here APT is used. So P1 means point. You have to give the code automatic processing tool. APT means P1, L1, C1, PL1. So PL1 means plane. A plane is defined by P1, P2, P3 points you have to give. Otherwise, a circle is having a center and radius. You have to give, otherwise you cannot form a circle. Line, definitely you have to give to 2 points, starting point, ending point. Points, 0, 0, 0. It defines a coordinate in the X, Y, Z coordinates. So here, you can see a line is formed. A line is formed with P1 and P2. Okay. And also here, circle C1 is formed, this radius. This radius is formed definitely with some radius. And one radius, one center point is there. So anything, center point they might have taken from here, P5, center point. So this is the y-axis, this is the x-axis. So here lines are there. If you want to form a line, this L1 line is defined by points P1, P2. Also, this is a sample part with geometry elements, points, lines, and circles labeled for computer-assisted part programming. So this is the commands you have to be remember in order to give the commands. Next, explain about the geometric statement. What is a geometric statement? This geometric statement is dependent upon same point P1. You have to give XY coordinate as I discussed before. Otherwise, you can give point into F L1, L2. So intersection of two lines. So lines can be formed in two ways. One is line P1 point, P2 point through 2 points are parallel to another lines. If line P1 parallel L1, this is circles. C1 is equal to circle center and radius is given. C2 is equal to circle P1, P2, P3 is given. So this is the geometric statements. You can see here, this is a geometric statement which is formed by using these commands, above commands, line commands, circle commands. This is the geometric statement is given here. Explain about motion statements. What are the explain about motion statements means? A motion statement in the cadcam, specifically APT, automatic program tool language, this is called as, defines the tool path for the CNC machines, which consists of commands. Go to command means the tool will go to. Target data, it will target the coordinates and surfaces. These statements guide the cutter along defined geometry, controlling its trajectory, way, directions, stopping points. So you can see here, ma'am, this is a circle. This is a circle made up of some center and also some radius here. Okay, you can see this big, huge structure. Maximum they are using this motion statement only. Okay, go to command is used here. Go to command, target data command is taken here. Why you want to define the geometry, ma? Control the trajectory motions and stop this one. Here you can see, here radius is given 40, here radius is given 60. This is the 60 circle they have made, ma. The curve is made. Here curve is made with 40, here curve is made with 20. So this is all motion commands you are given for cutting of the tool. So it may be coming for 2 marks. Here, 19th question. I'm going to explain about the post-processing statements. The post-processing statements in the CAD-CAM is a crucial final stage of CAM process. Is the CAM process acting as a translator. So CAM is generally understanding only G codes and M codes. Here, the CAD is giving design into CAM. CAM is converting into G code, M code, which are given to the machines. These machines will operate. This is the post-processing. The processing time where this digital data is converted to physical data is converted to digital. Converts neutral cutter location CL data generated by CAM softwares into specific codes, G codes and M codes. If G codes, M codes are not given, CAM software will not operate manufacturing operations because it is only able to understand G code, M code only. Otherwise, it is not having different languages to understand. Last question, 20th question I'm taking in the unit 3 of CAD-CAM of this one, NC machines and part programming. 20, explain about auxiliary statements. Some of the auxiliary statements I have taken here, ma'am. Cutter, you have to give diameter for the cutting, defines the diameter of the tool. Okay. Spindle, what spindle speed direction, clockwise, anti-clockwise, you have to give. Or at what RPM it has to cut, you have to give the values. Feed rate, the feed rate of the tool, specifies the feed rate in inches and minutes, inches per minutes or per minutes. Definitely will go inches per minutes only. Coolant, the code is given coolant, where the liquid is flowing between the workpiece and the tool in order to absorb the heat. Okay. Some of the other is flood, FLOD, mist off, we can give the coolant off, coolant on. Load TL means call for specific tools, whatever the tools you want. There will be a different tools available, tool number you have to give, the tool will come and exchange itself. Units generally taken in the mm and inches here, which defines the measurement system. Into L, out to L, sets the tolerance for fitting the tool paths. Here you can see this is a CAD file, part programming, CAM file, and also NC file, which is given to CNC machine. This is the post processing, CAD, CAM, and post processing. So this is the way how the part programming has been discussed in the part B, and also total part B is generally tool, cutter, hand cycle, basic components, adaptive section here, CNC, DNC, machines, tools, NC codes. This all is in the part A section. So hope you understand this video. So hope give some comments, which will be helpful for me making the next videos. And thank you for watching these classes. Please like, subscribe my videos if you like it, and also suggest for your friends for this post. Thank you. Thank you very much.